220、210、100、190、89、88、87、86、85、84、83、82、81、180。
打ち上げ3分前です。
It's 3 minutes to the launch.
全システムの電源が外部から内部に切り替えられました。
170。
The power has been switched to the internal systems.
1段液体水素系準備完了。
The first liquid hydrogen system has been pressurized.
150。140、39、38、37、36、35、34、33、32、31、130、29、28、27、26、25、24、23、22、21、120、19、18、17、16、15、14、13、12、11、110、109、108、107、106、105、104、103、102、101、100、99、98、97、96、95、94、93、92、91、90、89、88、87、86、85、84、
2段液体酸素系液体水素系準備完了。
The second stage liquid oxygen and hydrogen system has been pressurized.
74、73、
1段液体水素系準備完了。
69、68、67、66、65、64、63、62、61、60、59、58、57、56、55、
The cooling water system for the flame deflector has been activated.
50、49、48、47、46、45、44、43、42、41、40、39、38、37、36、35、34、33、
ウォーターカーテン散水開始。
31、
The
30、
sound suppletion water system has been activated.
27、26、25、24、23、22、21、20、19、18、17、16、15、14、13、12、
フライトモードオン。
10、
The flight mode is on.
動揺電池起動。
The thermal batteries have been activated.
全システム準備完了。
All systems are go.
メインエンジンスタート。
The main engine ignition.
12BA 点火。リフト。
Solid boosters ignited. Lift off.
プリズムスリムを搭載した H2A ロケット47号機は2023年9月7日午前8時42分11秒に種子島宇宙センターから打ち上げられました。
We have a liftoff of the H2A launch vehicle number 47 from JAXA Tanegashima Space Center at 8:42 and 11 seconds a.m. on September 7th Japan Standard Time.
打ち上げ以降ロケットの管制は吉延発射管制塔から竹崎総合司令塔に引き継がれています。
Following the liftoff, the operation control of the H2A has been switched from Yoshinobu Blockhouse to Takesaki.
60、
打ち上げ後1分が経過しました。
It's 1 minute into the flight.
70、
ロケットは現在東方向の太平洋上へ飛行しています。
The H2A is now flying above the Pacific Ocean to the east.
83、84、85、86、87、88、89、90。
SRBA 燃焼終了。
Solid boosters have burned out.
110、
SRBA 分離。
12、
Solid boosters have been separated.
15、16、17、18、19、120。
小笠原局でのロケット追尾が開始されました。
Ogasawara Station has started tracking the H2A.
第1段エンジンの燃焼は正常、制御系、飛行経路も正常。ロケットは順調に飛行を続けています。
The combustion of the first stage engine, outro control, and the trajectory are all nominal. The H2A flight is on course.
現在のロケットの高度は約 48km、148km、秒速約 1.9km です。
Current altitude of the H2A is about 148 km.
上部衛星フェアリング分離。
The upper payload fairing has been jettisoned.
打ち上げ後5分が経過しました。
It's 5 minutes into the flight.
第1段エンジン燃焼停止。
The first stage engine cut off.
第1段、第2段分離。
The first and the second stages have been separated.
第2段エンジン第1回燃焼開始。
The second stage engine ignition for the first time.
打ち上げ後9分が経過しました。
It's 9 minutes into the flight.
打ち上げ後10分が経過しました。
It's 10 minutes into the flight.
第2段エンジンの燃焼は正常、制御系、飛行経路も正常。ロケットは順調に飛行を続けています。
The combustion of the second stage engine, true control, and the trajectory are all nominal. The H2A flight is on course.
現在のロケットの高度は約 552km、 秒速約 6.0km です。
Calling altitude of the H2A is about 552 km and velocity is about 6.0 km per second.
第2段エンジン第1回燃焼停止。
The second stage engine cut off for the first time.
クリズム分離。
Clism separation.
クリズムの軌道への投入を確認しました。
Clism has been inserted into the orbit.
ロケットはこのまま完成飛行を続け、まもなく小笠原局の受信範囲を離れます。
The H2A is in a coastal state now, and shortly it will proceed beyond the tracking area of Ogasawara Station.
次のイベントまで一旦実況放送を中断いたします。打ち上げから約47分後にスリム分離を予定しています。
The separation of Slim will occur in about 47 minutes into the launch. Until the next major event, there will be an intermission.
竹崎総合司令塔からの実況放送は午前9時25分頃に再開を予定しております。
This live coverage will resume at about 9:25 a.m. Japan Standard Time.
We are watching the live coverage of the launch sequence. Crism is separated. We have received message videos, so please take a look at them.
I'm Richard Kelly from NASA's Goddard Space Flight Center, and I am very happy that we are finally on our way into space to begin a new journey with the X-ray imaging spectroscopy mission. I want to congratulate JAXA and the rocket team at Mitsubishi Heavy Industries for getting us this far. This took an enormous amount of work, and my colleagues at NASA are extremely grateful and wish to congratulate them on their success. Astronomers from around the world have eagerly anticipated the launch of CRISM and the new capabilities it will provide for high-resolution spectroscopy and wide-field imaging. We are now a major step closer to exploring the universe in X-ray light with a powerful new tool to reveal what is going on in so many celestial objects in our galaxy and all the way out to distant clusters of galaxies that are emitting X-rays due to their extreme temperatures and energetic conditions. We will soon bring this new observatory online and get to work. So congratulations and go CRISM team.
CRISM プロジェクトプリンシパルイン
I am Tashio, principal investigator of the PRISM project. TEMMA in the 1980s, ASCA in the 1990s, and Astro H in the 2010s. With their then state-of-the-art spectrometers, Japan always led the world in X-ray astronomy. This time again, the world's best spectrometer will be launched into the space. We are determined to use PRISM to capture the world's best spectrums to lead the world in X-ray astronomy. Please continue to support our mission.
The first video was by Dr. Richard Kelly of NASA, and the second was Professor Tashiro, principal investigator. Now we will be discussing PRISM in more detail. From PRISM project scientist Professor Matsushita, and from science operation team Dr. Shiratsu are with us. And about PRISM science research, I would like to ask of them. First, Professor Matsushita. Yes, I was watching anxiously, but successfully PRISM was separated to my great relief. Over the next 3 months, carefully, have to continue to be watching carefully, but first step was successfully done. 3 months after, scientific observation will be carried out, and we would like to be able to report the first light. About PRISM satellite, I would like to explain. Can I have a slide? And Dr. Shiratsu, please explain about the PRISM and detector. I would like to explain. Can you see the slide? Is the slide being shared? PRISM length is 8 meters, about 3 stories high, and 2.3 tons is the mass, and width is 9 meters when solar panel is deployed. Height is 550 kilometers, and it's at inclination of 31 degrees, and period is 96 minutes. From the space, X-ray arrives to the left top part of the satellite and will come into the satellite. In this cylinder, there is X-ray telescope. Using X-ray telescope, X-ray will be gathered. The focus of the telescope, the right bottom area, have 2 detectors. First is X-ray microcalorimeter Resolve. Resolve uses freezing systems, including liquid helium, and cooled to negative 273.1 degrees. And at super high resolution, X-ray will be observed. Next is X-ray CCD camera Extend. In comparison to Resolve, Extend has wider angle and will be able to observe an area of a sky equivalent to a full moon at a time. Using these 2 equipments, observation will be carried out.
So, from my side, the scientific research plan of PRISM. Dr. Shiratsu will give the latter part of the explanation. Then if you go to the website, you can see how to see the cosmic winds. How should I give the explanation on this? This is the topic I would like to talk about. As has been already explained, the telescope and detectors are on board. And what is X-rays? This is the starting point. X-rays are part of the electronic magnetic waves, like the ultraviolet as well as the lights. They are part of the electromagnetic waves with the high energy, with the short waves. X-rays cannot penetrate the atmosphere, and so the satellite is essential for the observation. As has been already explained, 1 million degrees and the 100 million degrees, the objects will be able to be observed by this X-ray astronomy. There are 2 detectors on board. The first one is resolved. This means the resolution and also determination. So these 2 things are contained in this term. Now let us compare the performance. As you can see, this is about the Astro H observation results. the clusters of galaxy, X-ray spectroscopy, and you can see the colors in the X and Y axis. You can see those are the two detectors that are going to onboard and similar to the ones that we have. The black represents the Astro H microcalorimeter, and the red one is a Suzaku CCD. The microcalorimeter, if it is going to be used, X-ray color, that is the axis you will be able to see how accurate it is. And similar to the sound, when it comes to the light, it is affected by the Doppler effect. If it is approaching, redshift, and this is going to be applied to the observation. X-ray color can be observed accurately, and you will be able to see the sources, or like the high temperature gas, and can be analyzed accurately. And on top of that, you can see chromium and manganese. Those rare elements, they are going to be X-rays emissions, as you can see in the chart. Those small, the minor, the X-rays can be detected for observation. And then X-ray space-based space. How is it going to be observed? When it comes to the Milky Way, you can see the near-infrared observation on the top. You can see the disk that spreads around. We are within this disk. And then X-ray has observed this galaxy on the bottom. In the bottom, you can see a different view. X-rays will use the emitted by the gases with high temperatures. In the case of the Milky Galaxy, you can see millions of degrees of X-rays can be observed. You can see the speed of the cosmic wind, and there are different the celestial objects. They are called supernova remnants. Those two remnants, the left one is about 300 years ago. It is the remnant of the supernova explosion, and it's 16 light years wide. And on the right-hand side, 11,000 years ago, there was the explosion, and 250 light years expanse. So you can see the effect of the explosion. CRISM will be able to observe X-rays emitted from those supernovas, and then we will be able to observe the elements and the speed of the gases. In fact, around ourselves, when it comes into those elements, they are produced in the supernovas. And as you can see, we will be able to analyze the alchemy of the space and the speed of the wind and the evolution of the galaxies. We will be able to detect them. And you can see this round object. These are the clusters of galaxies. Hundreds of galaxies are going to be combined together. And you can see this is the enlarged picture, X-ray picture, which is enlarged, and about 600 billion years away, with the expanse of several light years. And they are trapped in the high temperature gas in the core. And most of the elements in the space are produced and then exist in the form of a high temperature gas. CRISM will be able to detect these objects, and then how those objects are growing in the space-time. They will be able to be observed. And the percentage of the elements that were produced in supernova are spreading around, and we will be able to observe them. In the core of this stellar object, this is M87. And this M87, this X-ray picture can be captured on the left-hand side. From the galaxy, there is a high temperature gas is emitting. And on the right-hand side, this is the microcalorimeter, which captures the spectra, which is expected to be captured. the pinkish, the dotted line represents the Suzaku results. And the satellite will be able to observe the emissions of those gases from AM87. Then, how's the wind blows from this place?
Yes, thank you. Shiratsu speaking. M87 was just mentioned. In the center of the image of the galaxy in a white square, that is the center of the galaxy. In X-ray, we can see that it is very bright. And if this is enlarged further, it is about 6.5 billion solar mass. There is a supermassive black hole. It is known to exist. And such supermassive black hole is estimated to be at the center of each galaxy. Other than supermassive black holes in the universe, there are various black holes, including small and large ones. For example, at the right side, this is a different galaxy, and visible light and X-ray are superimposed. And looking at this, other than at the center of the galaxy, there are some bright spots under X-ray. And this is also a black hole. And these are paired black holes. And these are several tens of times larger than solar mass, stellar mass black hole. And these are circling each other in a very short distance. They are attracted by the strong gravity of the black hole, and they are falling into black hole as they encircle, creating a disk at the center. And the gas temperature is as high as 10 million degrees, emitting very strong X-ray, and that X-ray is observable in the image above. There are small and large black holes. They not only absorb things, but as Professor Matsushita mentioned earlier, high-speed gas is emitted. For example, on the left side, this is a jet, and light velocity is 300,000 kilometers per second. Speed is as fast as that, and the falling disk above that, there is a wind emitted, as shown on the right side. The velocity of the wind is several hundreds of kilometers to 10,000 kilometers per second. Earlier, rocket, when Chrism was separated, it was traveling at about 8 kilometers per second. In comparison, the speed is much faster. And in a supermassive black hole, these jet or wind are emitted, and surrounding stars and gas may be moved and affect the formation of the galaxy itself. That is the estimate. But why do jet and wind come from the black holes, and to what extent do they affect the surrounding environment? That is not fully elucidated. With a Chrism, we hope to be able to understand this mechanism. For example, as shown at left below, around the black hole, there is a wind, and let's say we observe this wind near the black hole. There are various types of X-rays with different levels of energy. And X-ray, the gas coming out, if we observe the wind, we can look at the element such as iron that will be absorbing a certain level of energy. And as shown on the right side, we can see a spectrum of absorbed energy. The wind is moving, and due to Doppler effect, from the original energy level, absorbed energy is observed at a little different time difference. And with that, we hope to be able to estimate the level of energy. And the black line showing absorbed energy, we were able to have very rough idea, but with the resolve on Chrism, each line of absorbed energy can be under energy, how much gas at what velocity are emitted to the surrounding environment, and how much it is affecting the environment. We hope to understand that better. And with X-ray observation, time-space distortion may be understood. That is also hoped. Near the black hole, because of theory of relativity of Einstein, there is a distortion of time-space, and EM wave that is emitted will be observed with distortion. The right side diagram shows the iron light line emitted from the black hole, and there are several peaks spread over widely. And this spread shows the distortion of the timeline. By understanding the shape of the emission line, we should be able to understand the degree of distortion of time-space around black hole. And black hole rotation, the faster the rotation, the effect is larger, and the range will be spread wider. So by understanding this, we should be able to measure the speed of the rotation of the black hole. Not only near the black hole, but at a distance from black hole, there may be a gas and wind that are absorbed. Then smaller emission lines and absorption lines will be mixed. With the existing equipment, it was difficult to distinguish, but with resolve, as shown in red line, various different components can be separated to understand the distortion of time-space around the black hole in more precise way. That is the hope, and in this way, so this is only a part of what we are hoping to achieve with the CRISM. We would like to understand the mystery, unravel the mystery of the universe using CRISM.
Thank you very much. And having listened to your presentations, CRISM has a very fancy name given to. The resolve means the dissolution, and then resolve also means determination and fortitude, and then extend. This represents extension of the idea, so to speak. Similar to CRISM, well, as captured in CRISM, how do you come up with a specific naming? Microcalorimeter, Rich Kelly, Mr. Calorimeter, AK, who has named this machine with the instrument in that way. Thank you very much. And the viewers probably are most interested in this topic, the distortion of space-time and black holes. And it is going to go up into 10 million degrees. And I am a scientist on the solar system, and then the temperature is like 1 million degrees, but it goes up into 10 million degrees. The flare is supposed to be the reason for this kind of creation. But in terms of the theory, do you have any specific ideas when it comes to the black hole, the temperature surrounding it? The gas comes down, declines, and it resolves and rotates at a huge speed. And then, as a result, the temperature goes up to 10 million degrees. So there is this theory, but theory is going to be corroborated and by the specific observations and by the result or the CRISM. And that's the process, and that the scientific mission is going to be made as for CRISM. Thank you very much and for your talk. Next, Slim.
I would like to introduce Slim to you, and we have a video message from the project manager. So please take a look together with the video introduction of the project. Hello to everyone watching this live streaming of SLIM, Small Lander for Investigating Moon. I think you're all watching the live streaming with much excitement, waiting for the launch of SLIM. I feel the same. It has been 7 years since the start of the project. If you go back to when the idea was originally conceived, it has been more than 20 years. With the support of many and efforts of all those involved, we are now welcoming the day of the launch. We have dedicated so much efforts and great deal of thinking in SLIM, with which we aim to achieve lunar landing with unprecedented precision, to open the door to the next generation of lunar exploration. We are determined to stay focused even after the launch. From the era of landing where we can to landing where we want. Please continue to support us.
近试了一个东西，真的很有用啊，所以要分享给大家，那就是太阳星全效克菲尔益生菌。吃了2-3天，真的有明显的感觉。最主要就是睡眠的品质变好喽。那你知道这个睡得好呢，整个人工作就可以更加的专注，当然情绪也就变得更好了。因为太阳星全效克菲尔益生菌，我才认识了这个克菲尔益生菌。它是由多支菌种益生菌所组合而成的，不但是能够维护消化道机能的正常运作，而且呢还有多种有益健康的保健功能，非常的强大。有台大教授专门研究它，把它叫做神仙的礼物。而您知道吗？有上千篇国际研究证实，克菲尔益生菌不仅是帮助肠道健康，肠道菌透过肠脑轴影响全身的器官，所以维持肠道菌种的平衡，这是解锁身体健康、精神健康的钥匙。对于帮助睡眠、维持好情绪，真的是很有感。也因为这不是药，有季节敏感、代谢困扰、关心恶性细胞风险的好朋友们，选择太阳星全效克菲尔益生菌，做好日常的保养，身体轻轻松松，没有负担。每日克菲尔，时刻美好 ，Good Feel Good， 请上快点购为健康下单，也记得输入推荐码，有额外的折扣哦。